lowering power formulas allows you to take an expression in trigonometry and reduce it from, say, being a squared down to being first degree. So, for example, sine squared of x is equal to 1 minus sine of 2x all over 2. So notice what happened. The degree changed from 2 and went down to 1. See that? That's why it's called a reducing power or lowering power. Why is that important? You have to be able to do that as you work through Calculus 2 someday. So again, you're in a pre-calculus course. So as you go on to take more calculus, this is one of those things. Not so important for our need moving forward, but definitely this is something that you want to be able to see. The cosine squared, that one's equal to 1 plus the sine of 2x. Whoop, I'm sorry, folks. Once again, I make a mistake. It's the cosine of 2x, not the sine. So you can see sine squared and cosine squared. You got a 1 minus cosine of 2x over 2 and 1 plus the cosine of 2x over 2. If you're wondering where those formulas are located in your large sheet that a lot of people take off to college with them and use, you can see the reducing powers formula right here. See, the sine squared is 1 minus cosine over 2. Cosine squared is 1 minus cosine of 2 a over 2. And then tangent will just be those 2 divided. And so we'll go tangent squared is equal to 1 minus the cosine of 2x divided by 1 plus the cosine of 2x. And those are the 3 formulas. What do they share in common? Yeah, all the formulas involve cosine, okay? And I just want you to know that when you get to calculus, some of you guys have come to my class, you've seen us starting to write these things on the board. They're amazing. They change the world forever. But if you try to do the integral of cosine squared of x dx, I get confused and I really don't know what to do. But if I can switch that and I can do the integral of 1 plus the cosine of 2x over 2 dx, now I'm happy, okay? Here I'm sad, now I'm happy. So just being able to relay some of those substitutions are important. So just 2 problems that we try. We'll have the rest of the time to ask questions and work. Rewrite the following expressions in terms of first power cosine. So notice first power. This is not first power. And notice cosine. This is not cosine. So I'm going to make a substitution. Instead of sine squared, I'm going to substitute 1 minus cosine of 2x over 2. And for cosine squared, I'm going to substitute 1 plus cosine of 2x over 2. We all okay with that? All right. And just take your time when you work through, okay? All right, let's multiply. 1 times 1 is 1. 1 times cosine of 2x is cosine of 2x. 1 times negative cosine of 2x is negative cosine of 2x. And then this is where people start to get confused. Negative cosine of 2x times positive cosine of 2x is negative cosine squared of 2x. Did anybody wonder, like, do we do something to the 2x, like maybe do multiply and all of a sudden get 4x squared? You don't do that. And I just want you to, don't write this down, but I just want you to think about this. If I have cosine of A times cosine of A, we write that as cosine squared of A. We don't write that as cosine squared of A squared. Like we didn't actually do anything to the actual angle. So leave the angle alone. We all okay? All right, that's a point of confusion that comes up. You can see why I don't want to do this over a video, okay? Because there's some little nuances here. What do I have in the denominator? 4. Yep. Sometimes, sometimes I'll write 2 because I think I'm adding, but the operation is multiplying, so multiply your denominator. What do you notice? Isn't that beautiful? The cosines just disappear. And so we are pretty happy at this point. 1 minus cosine squared of 2x over 4. So, is it written in terms of cosine? Check. Is it first power of cosine? No. Shoot. So now I've got a problem. I've got another cosine squared. So I'm going to have to substitute something in. And if we look at our cosine formula, we could substitute this in. But notice that this formula is for cosine squared of x. You don't have cosine squared of x, do you? You have cosine squared of 2x. We need a different formula then. And as long as you can get past this one step here, then you're going to feel okay. Cosine squared of 2x is equal to, well, there's going to be a 1, there's going to be a plus, there's going to be a divide by 2, and there's going to be a cosine. I can tell you that much. This is the part that you have to allow to sink in, okay? When I go from here to here, what happened to the angle? It doubled. So if I go from here to here, the angle will double. So it will be cosine of 4x. And there you've created a new angle. So that's actually part of the learning that people get confused when they're sitting in calculus 2 and they haven't seen this before. They start to wonder where the 4x and the 8x and all that stuff came from. Well, there it is. So now as I write this, I have 1 minus, and then we substitute 1 plus cosine of 4x over 2 all over 4. Do I have cosine? Check. Do I have first power? Check. So I'm good to go, except I have a complex fraction. So once I get rid of the complex fraction, everything will be fine. So you are almost done. The good thing is that you're really good with complex fractions right now. I'm going to change this 1 to 2 over 2. And notice, now that I have common denominators, as I subtract, I have to distribute my subtraction sign. 2 minus 1 is 1. And then I have a minus cosine of 4x. Sorry. Divided by 2, divided by 4 over 1. Multiplied by the reciprocal. And I get 1 minus the cosine of 4x all over 8. And now that is the expression. So as I started at the beginning of class, if I were to write the integral of that dx, I would say I can't do it. You would have to actually go through this process and rewrite it like that. Now, in calculus, I would be able to do that. Okay? So you've at least had that background. You realize you still can call me when you're in college. Evie? Any chance? I got a probably not. Ferris, any chance? Maybe? Oh, I got a maybe there. All right, we'll take it. Sine to the fourth. I don't really have a formula for the sine to the fourth, but I do have a formula for sine squared. So I'm going to substitute 1 minus the cosine of 2x over 2 times 1 minus the cosine of 2x over 2. Everybody okay with that step? All right, let's multiply. Is something in the middle going to cancel this time? No, it won't, will it? So I'll get a 1. I'll get a minus cosine of 2x and another minus cosine of 2x. So minus 2 cosine of 2x. And then my negative cosine of 2x times negative cosine of 2x would be positive cosine squared of 2x. That's all going to be over what? 4. Good work. So I'm pretty much at the same spot I was last time. Do I have all cosines? Yes. Do I have all single powers? No. I've got a squared. Time to get rid of the squared. 1 minus 2 cosine of 2x plus, who could tell me what I put in for my substitution for cosine squared of 2x? One plus cosine of 4x, good, over 2. We made up that one little formula. I showed you how to do it. Now we have we're all first power, great. We're all cosine, great. But now we are, unfortunately, we have a complex fraction. So let's just create a common denominator. I'm going to rewrite this as 2 over 2. I'm going to rewrite this as 4 cosine of 2x over 2 plus 1 plus cosine of 4x over 2 over 4. I combine any like terms. 2 and 1 are like terms. I get 3. Negative 4 cosine of 2x and cosine of 4x, those are not like terms. Okay? They don't have the same angle. They need to have the same angle, and they don't. So it's a minus 4 cosine of 2x and a plus cosine of 4x over 2 over 4 over 1. And so as I multiply by the reciprocal, I'll get 3 minus 4 cosine of 2x plus cosine of 4x, and it'll now all be over 8. There's multiple ways to write that, but that's one way. I'll write it a second way just in case you would ever see it. If you just divide each one by 8, so 3/8, and then cosine of 2x over, that would be over 2, and then plus cosine of 4x over 8. Like, you could write it like that as well. Either way is fine, doesn't matter to me. But so go ahead and take out your assignment from this lesson so we can take a glance at that. So when I first started teaching this content, the first thing you do is you pull from your experience when you were in high school. And sometimes that's good, but sometimes it's bad. Over the years, I've kind of seen where this is going. So as you look at this part of your homework, it says to lower the power of sine to the 4th of x. Have we already done that? Yeah, we did it, right? So you already have notes to show you exactly how it goes. Try to do it without your notes. If you get stuck, look back at your notes. Get my point? Have you already done number 10? Yeah, if you get stuck, look back at your notes, but try to do it without your notes. Have you done number 9? No, you haven't, right? So this is the one that's new, okay? The other two you've already seen. so hopefully they shouldn't be very bad for you. This one is definitely optional, cosine to the 6th, but it is a really good time. So, you know, if you, like, you know, basketball happens tonight, it's like 10:30, you get home, you're like looking for something to do that's really fun, go ahead and try 11. I won't judge you. It'll be a good time. So I think that that's definitely an option. So on a given year, normally we cover the double angle and the lower and power formulas in one day. I put one video yesterday and then this piece today. And so I'm now going to, you know what, folks? I'm going to continue the video for anybody watching in case they have a question on the front. So you can go ahead and start working. Anybody need to roll through one of these first 3 on the front together? Like you were a little bit confused or stuck. I'd be happy to help you set up. Sure thing. So this is all set up as sine of x. And we want to know sine of 2x, cosine of 2x, and tangent of 2x. So for example, suppose that you had the sine of 40 degrees. You would then be producing the sine of 80 degrees. You're producing the sine of double the angle, okay? So using double and single angles are important. They come up a lot in the exchange. As you notice, in what we just did, we went from single angle to double angle, didn't we? And so those relationships, they tend to come up a lot. So I always start out by writing this down. I always start out by writing sine of 2x, cosine of 2x, and tangent of 2x. And I always start with this formula. There's only one option for this formula, and it is 2 sine of x, cosine of x. And that relationship you do see come up in calculus a fair amount. We've seen it about 3 or 4 times this year. I will say by and large the calculus students do not remember this relationship. I give them a sheet of notes so they can look it back up, but this is important. If there's one that you can remember, it's this one right here, okay? So all we have to do is just plug it in. Can we agree that so far it's no big deal? Yeah, I mean, we haven't done anything difficult, have we? And as a matter of fact, they gave us sine, didn't they? I mean, it's pretty good so far. So we have 2 over 1 times 5 over 13 times cosine. With me so far? As soon as we do this one next step, the rest is easy. This is one of the most common IDK problems I get on the test from people who have no idea what I'm doing. Can everybody see it so far? I haven't done anything complicated at all. Okay, so if you know sine, can you find cosine? What is the most important formula in all of trigonometry? Sine squared plus cosine squared is 1. Now, see if you remember, as I'm trying to bring you back to things you've learned before, in number 2, you're not given sine or cosine. Do you remember the other formula in trigonometry that we're continuing to use right now that involves tangent? It's number 6 on your sheet. Does that look familiar? So you could use that and you would then know secant, right? And once you know secant, you know cosine. And then you could use that to find sine, right? So you can see it forces you to use different formulas together. You okay so far? All right, let's square that guy. What do you get if you square 5 over 13? 25 over 169 plus cosine squared of x. Whoop, I don't have to write a divided sign there. Is equal to 169 over 169. I'm now going to subtract 25 for both sides. I get cosine squared of x is equal to 144 over 169. Now what? Square root. So cosine of x is equal to positive or negative 12 over 13. is it positive or negative? If I'm in quadrant 1, they are all positive. Two times 5 is 10, and 10 times 12 is 120. 13 times 13 is 169. You have 3 options for cosine of 2x. I like to use 1 minus 2 sine squared of x. I think that's the best option. That's my favorite. We all have favorites, right? 1 minus 2 times, I have to square sine of x. You already have sine, don't you? Sitting right here. And we've already squared it. You get 25 over 169. So then it's 2 over 1 times 25 over 169, or 1 minus 50 over 169. I need common denominators, so 169 over 169 minus 50 over 169, 119 over 169. So that's sine of 2x. That's cosine of 2x. To get tangent, divide those two. 120 over 169, 119 over 169. This sheet. Nope, half angles we will do next week. And I will say this is definitely, the stuff you see next week is significantly easier than what you saw this week. So good job, folks.